All right, guys, welcome to the final installment of EM378 SI Online. Yeah, here we go. So, an engineer is to design a channel lined with planed wood to carry water at a flow rate of 2 meters cubed per second on a slope of 10 meters per 800 meters. The channel cross section can either be a 90-degree triangle or a rectangle with a cross section twice as wide as its depth. So, that's what's shown in the diagram here. Which would require less wood and by what percent? So this is a little bit of a different problem than our last one, um, but I felt it was probably representative of something you might see on an exam or just something fairly practical here is kind of an analysis between two different systems that you have. So we have a flow rate of 2 meters cubed per second given and a slope of 10 over 800 given. And what we want to do is we want to be able to compare their areas and their flow rates. So we're going to use this version of our open channel flow equation, right? With because usually sometimes we'll have velocity on this side, but so we can use the flow rate that we're given. We can just multiply everything by area. All right, r sub h to 2/3, and then slope to the 1/2. And for the rectangle, so this is going to be my sub r, and this represents sub t. So whenever you see something sub r, that's for the rectangle. Something sub t, that's for the triangle. So q sub r is going to be the same as q sub t, and the slope of that is going to be the same as the slope of our triangle. Both are 10 over 800. And we're going to assume that they're going to have the same wood in them, so they have the same Manning coefficient. I don't really need, so that's what that's going to be. So then we can do some substituting in here to relate r to t, and then what we find out. So if we set our qr equal to qt, where this is nr, nt, all that jazz, then we're going to get a relationship between area multiplied by r sub hr to the 2/3 is proportional to a sub t r sub ht to the 2/3. And remember the r sub h, just area over the, let me try that again, is just the area over the wetted perimeter. So doing that for our rectangle, that's 2 times y sub r squared. And then our wetted perimeter for our rectangle is 4yr, right? Just this plus this plus this. We'll highlight that real quick. And then that means that r sub h sub r is just going to be 1/2 yr when you put 2yr squared over 4yr. So for that, that's for our rectangle. Now for our triangle, area in our triangle, 1/2 1/2 times y sub t times 2 times y sub t. Right? So base times height divided by 2. That's kind of sloppy writing, but you get the idea. Well, let me focus. Focus. Wait for it. All right, cool. So then our parameter for our triangle, our wetted parameter, is this length plus this length. So that is 2 times square root of 2 y sub t. 1 second. And then, gotta silence my phone. R sub ht is then equal to our y sub t over 2 square root 2. All right. So then what we can do after that is substitute these things in up here and also our areas. And then, let's see, 1 second. Lost my notes here real quick. Okay, there we go. So 2y sub r squared times 1/2 y sub r to 2/3 is equal to y sub t squared 1 over 2 square root 2 y sub t to the 2/3. And then we can get a relationship between y sub r and y sub t. Whoops. Let me try that again. Y sub r 0.707 y sub t. So now we have a relationship between the two shapes that we have just based on the dimensions that we're working with. And since we know that use of wood, that's going to be proportional to parameters, right? For however large our perimeter is, that's how much wood we're going to need, because they're going to be going the same length. So we just need to compare their parameters and see what the proportion is there, and then find out which one would use less. So we'll do P sub t over P sub r, and substitute in our y sub t over here. So we get 2 over square root of 2 y sub r, right? Because that's that 1 over 0.07 is square root 2. So that's that substitution that we made up there. Or, hold up, that's supposed to be y sub t. Oops. There we go. And then this is, and then our parameter for our rectangle is 4 times 0.707 y sub t. There we go. And so these will cancel. And then, funny enough, this also cancels, and we get the proportion of 1.00, which means that both would use the same amount of wood. So kind of a weird result, not exactly what you'd expect necessarily, but that's the relationship that we get, right? So it's been a good semester, everybody. I'll still be available up until the final, so if you have any questions, make sure you're either leaving those in the comment section on the YouTube channel, or sending me a message through the SI website. Either way, I will try and get to you in a quick fashion. I'll try and be efficient about that, because I know you guys might have questions, but hopefully this YouTube channel has been helpful for you in this online transition. All right, I will see you guys around, hopefully.